Welcome to my channel. Today we are going to see the Simatic S7-1500 or 1500 redundant systems. First, let me check the difference between the redundant and hot standby PLCs. Redundant system means a secondary unit is operating in parallel with primary duty and both are sharing the demand. Standby means a separate unit that is not operating parallel with the primary, but both are tightly synchronized with between the primary and secondary PLCs. Let's see some difference between redundant and high availability, that is hot standby PLC. Both CPUs are similar, but there is some differences such as synchronization. For the redundant PLC, the Profinet ring or MRP is used. For high availability or hot standby, synchronization module or fiber optic cables are used. In both cases, hot standby can be occurred with different speed rates, and in both cases the IO systems can be supported. Example, ET200SP and ET200MP can be supported for as IO redundant system. In this slide, you can see some differences between each CPU model and its program data capacity and data memory capacities, and also the interfaces between each one. So you can select based on that, and also you have fail-safe module as well in new CPUs. Let's double click the Simatic TIA portal version 16 or which one you have. Once the program is opened, you can see from the left side start, and from the middle one you can see open existing project, open new project, migrate projects, and welcome tour, first step, etc. In our case, we are creating a new project, so click the create new project. Once you click the create new project, the new page will be appeared for creating a new project. From there, just enter the project name, path, and it will show the default version, author, and commands. From the project name, just enter the name of the project, what you are going to give for this project. In our case, I am going to give S7-1500 or 1500 H_redundant. Once I press the create, it is creating a new project called S7-1500 H_redundant, and this is the path. You can find the path in the same place. Okay, so once it's now creating a new project, it will take little bit time. Once it's created, you can find a new window. In this window, you can see start from this below start. You can find device and network, PLC program, motion and technology, visualization, and project view. In our case, this is a new project, so I can open either configure a device or open the new project view. So I will click the configure a device. Once you click that configure a device, you can see show all device, add new devices, new device. From I will press the add new device currently, and you can find here some default controllers, PCs, and HMIs. For our case, see here, this is the PC system. PC system means this is for SCADA systems. Okay, WINCC. And in our case, we need to go for controller. No? So I will click the controller. Once you click the controller, you can find all the different types of controller. S7 1200, 1500, and from the 1500 or 1500, I can select either CPU 1515R or CPU 1517H. This is the two different redundant and high availability module available in the Siemens S7-1500. Just if you click inside still, you can find the parts. See, this is the part number 6ES7-5173HPOO, and if you click that model, you can find the article numbers here, and you can find the CPU, how it looks, and the version, firmware version, and also the complete detail of the CPU. And if you need to add, just click the add, it will be add automatically. But in our case, we will add this configure network. No? So I don't need to add here. So instead of that one, I will click the configure network. So this is one way also to create a CPUs in this configuration network. And in the right side, in the hardware catalogs, you can find the CPU. The same CPU 1517, see here, and just drag and drop the CPU. Once you select and drag and drop the CPU, it will come with redundant or standby high availability systems. See here you can find both CPU primary and standby. Both are connected with Ethernet PN-IE_1. This means it's already have the primary configurations, a primary and standby configuration. Now again we will go for the slide. See here you have S1 mode, S2 mode and R1 mode. If you see the S1 mode, this means single phase interface S1 device. See the IM module, it's connected with primary interface only. So you have one connection to the one PLC. If you go for S2 mode, the primary PLC and backup PLC both are connected with IM module. So here it can be switched between the two connections. If you go for R1 mode, here the primary PLC is connected with one IM module and the backup PLC is connected with another IM module. Each interface has each one different connections with different PLCs. Also we can see the behavior of Profinet devices with single system redundancy S2. Initially the system, the primary and backup is connected with the CPU, the IM modules. If you see, if the CPU fails, the primary will be disconnected and the backup PLC run act like a primary, and the backup will take from S2 directly, and all the signals IOs are exchanged without breaking any datas. And the hot standby failovers time is less than 50 millisecond or 300 millisecond. In our case, the time is adjusted automatically and the IOs are exchanged between the primary and hot standby continuously within this millisecond. The supported IO system considered as below are ET200SP, ET200MP, ET200 Eco, Profinet, and also PN coupler, and also ET200SP high availability. And also the accessories for Simatic S7-1500 for high availability are synchronized module SFP, and this is for small and for plugging, and also we can use for fiber optic cables. Again we will move to the program part. If you double click the network view for the CPUs, you can find the device view. In this device view, you can find the PLC1 and PLC2 both. Okay, and also if you go for the CPU in the right side of the catalog, now we need to be moved to the ET200. No? So we need to be go here as distributed IO. Here you can find lot ET200SP, 200 SPHA and 200 MP, everything. So in this ET200 SP you can find IM 155-6 PNHF. From here there is two modules available. Out of that one we can drag and drop, and once you drag and drop the module, it will become as IO device for IM with interface modules. See, and I will drag and drop for 3 modules currently: device 1, device 2 and device 3. If you see all, it is showing not assigned. So now we need to assign these IOs as well. And also we will move for HMI because we are going to add 2 HMI here. So I will go here, there is basic panel, and also if you go for comfort you can find the big size as well. And here I am going to select here 19-inch display, 2 quantity. So I'm going to select this model TP1900 comfort, and I will drag and drop the module here. It is taking a little bit time. What's the module added here? I will drag and drop second one as well. Now both HMI are added, and now I'm going to assign this IO device in this Profinet primary and standby. No? So I need to assign this. So I just drag and drop to this any one of the CPU. See, once I drag and drop, it will come like this. And similarly for the second one as well. See here. Just drag the IM module and drop in the PLC part for the PN and PN IO signal. So it will be coupled together all true. So it's very easy, drag and drop in this R standby PN coupler. See, it's added all three together, and you can see the detail of this IO module as well. And if you see all three, it is showing PLC1 only. But in our case, we need to be add both, no? PLC1 and PLC2. See, if you see here in the PLC, any of the PLC, it will show the detail. No? So in the properties, you can find which one it's connected with which PLC like this. See, if you click any one of the property of the PLCs, you can find the general properties of the CPUs. See here. Just I will adjust the property of the PLC. Currently all the IO devices, IO device 1, IO device 2 and IO device 3 are connected with PLC1. So we can see here it's mentioned already the PLC1, no? All the IM devices, it's connected with that. So click the property. See here you can see the general property of the PLC1. No? See here, just I will minimize and I will show you. See here, just go down and you can find the property of the PLC1. See here you have option to make a auto hide also. Sometimes it will be auto hide directly. So just click the properties and you can find here, this is only for Ethernet property. See this one. Okay, in this Ethernet property you can find only the IP address, time of day synchronization and some advanced options. Okay, if you click the Ethernet IP address, you can find the Profinet and the IP address, and also enable some switched communications and these details. If you go for media redundancy, you can find here there is one button called domain settings. Double click the domain settings, and if you go further down in the domain settings, see here you have Profinet IO systems. In this Profinet IO systems, you can see the Profinet speed also, default speed 100 milliseconds, and you can see the PLC1 and PLC2. If you go further down, you can find the devices, what devices connected currently with your CPUs. See here you can see no device in the ring. You just select the IO device 1 for as client, IO device 2 and 3 similarly for as client, because the MRP role should be client, and the third one is manager, because this is the CPU should be manager, and the IO 3 devices should be client. So this is the main configuration we have to make in Siemens S7-1500 redundancy systems. Then only it will be configured as redundant system for these IO devices. Okay, next step, if you click the same Profinet redundancy, you can see here there is some interface options also. You can configure for call the program and also for errors and everything. And if you click the Profinet cable itself, you can find the same hardware configuration. See here, you can see the 100, no? There is number Profinet IO speed. You can change here. Even you can change the address of the Profinets. So this is the beauty of this Profinet interface. You can configure individually for these systems. If you click the CPU, you can find here, see here, you can find the cycle. See here in this cycle, you need to put 3000 the value range. If you put 1000, when you are making save and compile, it will come error. So you have to put the maximum cycle time should be 3000, and also this minimum cycle time should be 10, and this will be enable minimum cycle time for cyclic OBs, because this one you have to enable. Default it is enable only. You need to be keep the same. So these settings you have to keep 3000 and 10. This is the minimum requirement in the configuration of hot standby or redundant configurations. And if you go for synchronized module, here you can find the synchronized. See here, you can find the synchronized module downside. Just drag down, you can find the, see this is the article number for the synchronized module. So in our case, if you need to change the synchronized module, just go for right side of the hardware configuration. See here, you cannot find directly because now this you are in the general configuration. So double click the CPU. But before, see in the CPU you cannot find also. We see you can find only the general like communication interfaces only. In our case, you need to be select the CPU. Double click the CPU, it will go to the device view. Then you can find the configuration. See this one, double click, it will be in the device view. And here in the CPU, in the synchronized module, see you can find two synchronized module. So select that one and drag and drop to this module. See, once you drag and drop to the module, it will be open the change device synchronization module, current device and new device. See here. And if you need to change from here, and this will be change your synchronization module automatically, because now sometimes you will change some module with different synchronized module. So at the time it will be useful to us to change this configuration. So this is very important point in the redundant configuration and also for synchronization purpose. So once you configure these modules, see now we configured the CPU, and now I am going to move for IOs ET200. See here, we currently have only the IM modules only now in the ET. So just I will go there, and this is the device overview. So just minimize this one, go to hardware catalog and see here the ET200, what are the modules it can support. It will show you everything in this list. So select which one you need in this place. So I am going to select now one of the DI. See here, select the DI 24 volt 8 DI channel. I will drag and drop in any one of the 6 modules. See, I will select for the first channel, and this is for DI, and for DO it will mention DQ. Select DQ for this is 4 channel, this is 4 channel. So I will select this 4 channel 24 volt DC, and I will drag to this place in the second module. Okay, for the third channel I will copy paste this one. You can right click, copy paste, or Control C and Control V. It will be automatically copy paste these channels. So this is the one way, otherwise you need to drag and drop from this place. And I will go for the AI. This AI I will select any one of the module from this AI. See here you have a lot of modules, na? AI 2I, 8I or 2U or I means voltage or current modules, and you can select 2 wires or 4 wires as well. And I am selecting this one 4 AI, 4 into 2 AI, and I will drag and drop to this place. See here, and you can see the same time you can see the properties of that one. If you select, you can see the downside, the properties of the device, each device. Okay, now we already selected for one of the ET. Similarly we can do for all the ETs. Okay, and now I am just selecting for AQ as well. See, this is the AQ true into I ST. Okay, and I select, and you can see the properties in the downside of information as well. And also I am going to select one more module called server module. See, this one in the server module, this is useful to communicate with any one of the special services. Na? At the time you can use these technologies, for example technology modules, motor starter, special server modules, this type of things. See, I can add the server module, and this server module can be support for use data exchange between the IO modules as well. Now we will see the properties of each one. See here the first DI, you can select the channels, and you can see each channel, even you can adjust that channel activated or not, and also the input delays, and also you can select the IOs as well. IO, see the start address and end address, you can select either automatically or by manual. And also you can select the organization blocks directly also. So you have lot of options to select this. And also if you go for IO tags, you can find the IO numbers here. And also for this is for output, and this is for output as well. And also you can find for analog input. See here the digital output itself. See, you can find here the IQ. And if you go further for AI, you can find percentage IW1, and also if you go for analog output, you can find percentage QW. So this is the address. If you don't know, you can find the address from here, the property of IO tags itself. And if you go for general further, you can find the properties of, see here, the inputs, and you can find here the diagnostics here. No log, no supply voltage, overflow, underflow, wire break, and everything. You can select for each channel, you can select the channel properties. See here, 60 how much hertz, what is the measuring range, and also the smoothing speed and measuring types. And you can select either 2 wire or 4 wire or deactivated. Anything you can select in each channel, you can select with the property types, range, smoothing, and also the frequency range also. Okay, so this and also if you go for commonly, you can select the underflow, overflow, wire break, and everything. This is general. Okay, for the each module. So once you select these things, you can see further for the other details. Example, if you go further down, see here you can find all these 4 channels. So if you go further, see here you can see in the network view, I can do the same thing for the device 2 as well, and you can just drag and drop some DIDOs for currently. See, just I will put one DI, and also I will select the one DO, sorry, 2 DO, and I will select one AI, and select the AO as well. See, once we selected all the 3 IO devices, just save the project, and you see now almost we done all the parts, but still I did not configure the second PLC, because you see all the PLC is showing PLC 1 only. See, for the third IO device, just I will double click. See here, sorry, in the network, see, just I need to configure this HMI as well. But this HMI I will configure in the first port. See, this one directly I will click the port and I will drag and drop. It will automatically create the Profinet port number. See here, this is port number 2 and this is port number 3. The PN numbers, and also if you see here, you have the CPU. Okay, there is 2 ports separately, so I can select, and you see here this is the IP address P192.168.0.1. but if you go for the another one, see here the CPU, you see here, you can see the different IP address. So the subnet itself, it is different. See, I selected here 192.168.1.3. There you can see 0, but here you can see 1. So the subnet itself you can change for each. Example, for the HMI we connected with different ports, and for the other interface device we connected with different ports. See here. So once you see, if you see here the Ethernet ports for each IO device we connected it different, and first CPU is connected to one HMI and second CPU is connected with the second HMI. See here, I just all this I connected with multi assigned. Okay, I will show you how to connect this multi assigned. And also if you see here, all these connection types you can find here in the connections. If you see email connections, FTL, ISO, S7, TCP, UDP and everything. So if you see the relationships, and you can find the relation of each one, and also if you click this IO, this configuration, you can see the complete detail of each port. Okay, the IP address and everything. See this button. Okay, so once this is the overview of network. If you go for topology view, you can find all the IOs, like all the modules separately in the topology view. And if you the right side, see here, you can find all the ports, where it's linked and what is the slots, everything it will mention that with detailed for each one. See here. So this is the topology overview. Okay, but for this network configuration, network view, you can find that, and also if you go for device views, you can find individually each device. See here. Okay, if you click particular device, you can see in the left side, you can select the particular device, IO device. So you can, which one you are selecting, you can see the particular device views only. See here, you can click and you can see the details of each IO, what is the IO range, everything. And if you, this is the overview of device and networks. And if you go for left side for the change, see now I just compile this one, double click left side, and you see there is some errors. I find there is 2 errors. No? So this is the one before I told you, the cycle, IO cycle should be changed as per the convenient. See here, the accepted IOs data should be, maybe I will add 10. See the 10, that watchdog factor does not meet the criteria. In this case you should exceed 111 above, because if we put 10, so it is not accepting. It should be more than 110, 11. So you can find this detail, like example C for the Profinet speed. This is for real-time settings for IO cycles. So you have to change this one. If you see in the right side, you can have the drag and drop. You can select the more than that range. See here. See now it's not looking any error. Just I'm saving the application now again. I will just go right click the CPU and I will compile the changes. See now before there is 3 errors, now we have only 1 error, and you see the same thing. Change this one as well. Update the accepted cycle without IO data. Once you updated, it should be also more than 111. I will keep the same 250 and save this application. Now you check, there will be no, I hope there will be no error. It is compiling currently, and see it is checking the diagnostics at configurations like system configuration, everything. See currently there is no error, and only there is some warnings only. This will not affect our application. Now we will move to this again, to these supported devices. See here you can find the Siemens and also the scalable switches and everything. So this everything it can be used in this project. So I am just showing you how the redundancy and how the backup is going in single MRP as well as high availability devices. Okay, here you can see all it's recommended 16 up to 16 IO devices, and you can see here for the conventional and with IO links. In the conventional we connected all the IOs directly with the ET200, and if you see here another one, the IO links, it is connected. We already told that we can use it can be used to some special modules as well for the IO links. If you go further, you can find some coupling of multiple MRP rings. Here if you see here, the primary and standby is synchronized and the MRP is connected. There is 3 rings connected with the network. And if you see in the 3 networks, and each one connected up to 50 devices can be used in this specification. And if you go in our example again, see here you can find all are connected with multiple, and all the devices it's assigned with the both CPUs currently. See if you double click that IOs, you can find the properties of each IOs we checked before. The same, but you can find, see here, just I will drag the properties. Once I adjust, I am seeing the device. This is for diagnostics. Just click the property and you can find the property for each IO. See here, it will show the digital input module details, and also if you see further down you can see the module parameters. If you click the module parameter, you can find the channel templates. In the inputs of channel templates, you can find the speed of each input delays. Like example, it's already having 3.2 milliseconds. If you go further down, you can change that speed as well. And if you go further down, you can find the, see here, the input parameters if you click the input parameter, you can find you can change even for the particular IOs as well, for the speed of particular IOs. And if you go further inputs here, you can select the diagnostic for no supply voltages. Also you can select, and also if you go further parameters see down, you can find the parameter settings for also. And also if you see here in the right side of the DI, you can find the fail-safe module as well. This can be used to see here. I'm just showing the another example. I will just delete this IO. Instead of this IO, I will show you the fail-safe. This is another scenario for our case. See here. If I click the fail-safe, you can find the IOs in. See now it is going to add with. See, it's mentioned already yellow color. No? This means it is fail-safe. This DI, once you added this DI properties, you can find the something with different properties in our IO channel. I will show that one. What is the difference between the normal DI and the fail-safe DI? Still, it is not added. Just wait for a few seconds. See, it's added now. Now if you see these properties, see here, you can see here there is potential group, fail parameters, fail safe parameters, DI parameters. It's showing, see here, yellow color as well. See, this fail safe module has some additional properties. Okay, see here, if you see the potential group, double click, you can see here enable use the potential group on the left module or enable. See here, you can see this all, it is like additional parameters you can adjust as per your requirements. See here, you have monitoring time, source address, destination address, and also the failsafe parameter signature. And if you see here further, you can see each and every signal have the sensor supply, and you can see the short circuit test startup, and also if you see each one having the supply like sensor supply sensor supply as well as sensor evaluation and everything. If you see the IO device, it is looks similar, but if you see each channel parameter, you have lot of addresses, like lot of specifications you can adjust as per the requirements from the clients. So this is the difference between the fail-safe and normal. In each one have the sensor supply and you can adjust the ranges. But if you see the normal, there is nothing like that. Just you can use as normal DI card. Just I will drag and drop the normal now again. Okay. See, this is the normal case. See, you have just general from this, only these 3 points only we have, and this is the general IOs, which we seen before. See here, you can select no supply voltage or short circuit to ground and wire break. These three options if you select, whenever these options triggered, it will be give alarm, like it will give you the signal for this. So if you go for the DA configuration, you can find, see here, the value status. You can find the quality information as well. See here. Okay. If you select the value status and save this one, so whenever there is something, the value is wrong, it will show you the bad quality like this. So this is very important point also to understand the quality information. So this is the overview how to configure this device and how to configure the IOs of ET200 and everything. Okay, the next one we will go see here. There is nothing added as for Dynamics example. So how I can add? See here, there is option called GST, manage general station description files, GST files. From here, see, this is the default which we added earlier. So if you have the files here, it will take automatically detect for us. But in our case, I have some GST file for Dynamics. So currently it is not in the application. So download that one from the internet, GST file. See, I am browsing the GST file currently. And in our case, see, I keep this one in the desktop. And I put the name called GST. See here, GST file. And select the folder. Okay. Just in the desktop, select the folder. See, it is updating. See, you have two GST files. Okay, version 2.34 and version 2.25. I can select both of the GST file and I am importing the file. Once I import the file, it will take a little bit time because this file should be in XML file usually. This GST. It's having the complete parameter of the particular device. Example, if you have VFDs, Dynamics VFD or Altivar VFD, you need to take the GST file from the vendors and you need to import this file in the Siemens TIA portal. Once you import the file, this will take time to retrieve the GST here. See, now it is processing the GST file. This GST file can interlink between your VFD or any soft starter or any device, third party device, and it will communicate to our system. And this one have the complete parameters such as the complete detail of the instruments, the memory address or registers or what are the parameters you can read. It will have everything in this file. So whenever you are using third-party protocols, third-party device, you can use these GST files. See, now our GST file is completely installed and it is updating currently. And once it's updated, we can see this same Dynamics in your library. See, now currently it is updating the hardware catalogs. And it will take a little bit time to update the hardware catalog. See, it's updated currently, and now I am going to browse from the right side. See, in the global libraries, I did not able to find that one, so I need to go to the normal library. But I will do that before that. Just I will click the device configuration of the PLC. Just I will open the network configuration, because once I find the GST file, I will drag and drop into the network configuration. So I will double click the network device configuration at initial state. Currently it is trying to open the PLC configuration. See in the device and networks. See, it's opening now. And I will go to the network view. See, from the network view, just what I will do now, you see here in the catalogs, you can find that. See, I need to search for this Synamics. Either you can type here Synamics, or you can go to the particular place. See, once I type the Synamics, see here you can find in the inside the other field devices. You can find in the Siemens AG, and it is there. See, Synamics. There is lot of Synamics modules available in the catalogs. So select any one of the Synamics. See, and I will drag and drop. See, now you find Synamics DC motor. Okay, just it's showing that it is not assigned. So I am going to assign this module now. As you know that, just see here, right click. See here, assign new IO controller, and you need to assign for which place. See, just I am giving for the first one PLC one, so I need to give second one as well. So just again right click and give assign the new IO controller, select the second one as well and give OK. See, it is assigned for both. So if you double click the Synamics, you can find the properties of this device, and if you click the property, you can find the IP address, how to interface, and what is the device properties. Everything you can find in these properties. See here. So you can find all the file names, revisions, firmware details, and Ethernet IP address, general properties. Everything you can find here. See, and also if you go for system constants, you can find the, see here, which port is connected with which device, and how it's like what is the hardware types, hardware identifications, and users types. Everything is mentioned there. And if you go for, this is for port 1, and also similarly you can find for port 2 as well. And you see here, this all now it's connected in the network. See, even you can find the real-time settings, port settings for each port and everything. You can see in the detail in the general properties. This is the overview how we can configure the complete systems. And if you see, now I am compiling the hardware configuration, and it is compiling the complete configuration. I hope there will be no error, and it's compiled. See, you can find everything is okay now, and you can make the software configuration as well, compile as well. And if you see, is this is all general. See here, it's mentioned that SS level and this type of things. No issue for this. So you configure, and if I go for software rebuild, see, it is building the complete, because we make only the configuration, we did not make any program part. So it is compiling, and you can see there is no error. So you already configured the complete overview of redundant configuration of S7 1500 or 1500. And if you see here for simulation, just select the simulation, start simulation, and it will, you can see this, see it is now started the simulation mode. Okay, before starting the simulation mode, you need to check everything is okay, that PC configuration and everything. If you have any clarification, you can check for the previous videos for the simulation mode. And see, now the simulation already opened, and we need to be download the application and go to the online. These are the things we need to do for any types of simulation mode. See, it's taking little bit time to make a simulation. See here, you have the CPUs, and you can find here the connection types to interface. There is direct 1x1, 1x2, PN, IE, and also there is many. See here, slot 1x. You can select exactly the which one you need, and start search. You can find the target devices. See here, you can select the CPU 1, CPU 2, any one of them. Just select any one of them and give start, and after that you need to load this application. This is the overview how to make the configuration and how to select for simulation and also for physical device as well. In the physical device, the PGPC interface should be the physical. See, and after that you just go to the download to device. Once it's downloaded, you can see it will come same like extend download to device. Then you can select the particular port here again. And select the particular CPU and give load directly. And also you can see the only the display error message only also as well. So these simulations we made many times in the part 1, part 2 as well as part 3 as well. So you can check that how to make a simulation. Okay. So once you go to the online, you can verify complete signals, and if you have any program, you can verify the program as well. Okay, once you can see the simulation looks like this, and you can select run, and it will be run automatically. See, just like here power on this simulation mode. Now we'll move to the next part, which is the restrictions for S7-1500. Here, if you see here, the central use of modules, I/O, communication modules or system power supply for redundant or high availability. There is no redundant and high availability. And if you see the S7-1500, there is redundant, yes, hot standby, yes, and Profinet you can find MRP ring for redundant, and others you can use any one of them, any. If you go for use of redundant systems, you can shared IDs, yes, no, for redundant, and others S7-1500 we need to use shared device, yes, it's required. If you go for the Profibus devices, we will use for redundant case, yes, via coupling PLCs. In the other one, you can use also for redundant case. And if you see for the other communications like S7 communication to the clients, there is no communications, and for others, yes. And if you go for OPC-UA, for redundant, there is no OPC-UA server. For others, yes, we can use OPC-UA servers. For supported edge communications and supported redundant IOs, and also for MRPD synchronization, there is not supported for redundant. With IO links, yes, it's supported, and firmware update in runtime, it is not possible, and for DHCP because it should be fixed. This all it will be supported mostly in S7-1500 normal CPUs. Thank you for watching this video. If you like this video, kindly press the like button and share to your friends. Thank you.